Hi, this is Stu Schwartz from MasterMathMentor.com. Early in January of 2022, I kept seeing crazy messages in Facebook with green, yellow, and gray squares. I had no idea what it was, but I quickly found it was people posting their Wordle solutions. I played the game, and I was hooked on it and still am. For those of you who are still in the dark about Wordle, it is a game that asks you to find a 5-letter word of the day by guessing and getting feedback as to whether each letter is in the word or not. And if so, is it in the correct position? There's only one word per day. It didn't take me long to figure out a way to incorporate this concept into a game of my own. Digital. Let's see how digital works. The goal of digital is very simple. We want to find a 5-digit number. It could be a number like 67251, where all the digits are different. It could be a number like 83293, which has a repeating digit 3. Or it could be a number like 04940. This has a leading 0 and 2 of the digits 0 and 4 repeat. Once you type your number in, you will get feedback for each digit in the form of a color. If the background is green, then you know that the guessed digit is in the number and is in the correct position. If the background is yellow, then you know that the guessed digit is in the number but not in the correct position. And if the background is gray, then you know that the guessed digit is not in the number. Let's see 3 examples. Suppose our guess is 50481. Our feedback tells us that the digits 1, 4, and 5 are in the number because of the yellows and greens, and the 1 is in the correct position. Therefore, we know that 0 and 8 are not in the 5-digit number. Suppose we change our guess and we now say 47251. We now know that the 1, 4, 5, and 7 are in the number, and we have now that 1 and 4 are in the correct positions. We know that the 2 is wrong. Finally, we switch the positions of 5 and 7 and decide that the other number should be a 4. And our feedback tells us that we have it because we have all 5 green. Note that we have 2 4s in the 5-digit number. Digital would be dull if students just had to guess a 5-digit number. In Wordle, all 5-letter guesses must create words. So stare is okay, chili is okay, but PRIMG is not okay because it is not an English word. In digital, 58641 is okay. 23438 with 2 3s is okay. 05566 with a leading 0 and 2 5s and 2 6s are okay. So the premise of the digital game is that the 5-digit solution is a permutation of digits found by solving math problems from the following courses: Calculus AB, Calculus BC, AP Statistics, Pre-Calculus, or the SAT, ACT exam problems. Let's see how digital is played. We first go to the digital AB Calculus page, which is the only digital page up and running yet on the MasterMathMentor.com website. We will see all the 32 AB topics, each with a 3-digit code. Let's pick the game sample number 999. We will click to download it. When you download, you will get a PDF of the 6 problems. After directions, there are 5 problems based on the topic chosen that have single-digit answers, and then problem 6 that has a 5-digit answer. Teachers playing digital with their class may choose to project this PDF to the entire class. All of these puzzles fit on one page. For all puzzles, the digits of problems 1 through 5 comprise the digits of problem 6. For instance, suppose the correct answers to problems 1 through 5 are 7, 8, 4, 0, and 8. Then the answer to problem 6 must be a permutation of those digits. For example, it could be 0, 4, 8, 8, 7. So, solving the digital puzzle involves some permutations of these digits. The puzzle answer could be 87048, 78048, 88740, 07848, or it could even be the actual number 6 answer of 04887. So to solve the puzzle, we must first find the digits, and that means solving the 6 problems. When first presented with the PDF, students have a choice. Their first choice is they could choose to solve the first 5 problems, each having single-digit answers. These problems are usually easier and involve just a couple of steps. The advantage in doing so is that when solving the puzzle later, if a problem is incorrect, a student will know exactly the problem they got wrong. Choice 2 is to immediately try problem number 6, having a 5-digit answer. This math problem is usually harder than any of the single-digit problems and will involve multiple steps and possibly concepts. And getting it incorrect is an all-or-nothing affair. When putting the digits into the puzzle app later, getting one digit wrong means that this entire problem must be checked, which could be time-consuming. Let's actually solve the problems. If you are not particularly interested in the solutions of the problems, fast forward about 3 minutes. Since this is a sample, then each of the problems are based upon different concepts in mathematics. Problem 1 is based upon the SATs. The ratio of m to k is 1 to 4. The ratio of n to k is 2 to 3. If the ratio of m to n is calculated, what positive integer less than 10 can represent n? We translate our two statements as m over k equals 1/4, and therefore k equals 4m, and n over k is equal to 2 over 3, or 2k is equal to 3n. In that last statement, we will replace k with 4m, so we have 2 times 4m is equal to 3n. That gives us 8m is equal to 3n, and now we want the ratio of m to n, so m over n is equal to 3 over 8. Realize that n can be any number we want, but we want it to be an integer less than 10, and therefore n has to be 8. Problem 2 is an AP Stat problem. A company requires testing of its employees monthly for COVID. The average number of COVID tests an employee had in a month was 3.15, with a standard deviation of 1.06. If the distribution of testing is normal, the top 20% of employees in terms of testing have had at least how many tests to the nearest integer. This problem will be done on the calculator. Since this is a normal distribution, the top 20% means the 80th percentile. So using the calculator, we will use our inverse norm function to get the inverse norm of 0.8, with a mean of 3.15 and a standard deviation of 1.06. We get an answer of 4.04 tests, which is approximately 4. Number 3 is a trig problem. The equation 2 sine squared of x plus sine of x is equal to 1 has how many solutions on the interval 0 to pi? To solve, we set the expression equal to 0 and then factor. It factors into 2 sine of x minus 1 times the quantity sine of x plus 1 is equal to 0. 2 sine of x equals 1 gives x is equal to pi over 6 or 5 pi over 6 on the interval 0 to pi. Sine of x equals negative 1 gives x is equal to 3 pi over 2. However, that is not on the interval 0 to pi, and therefore there are only 2 solutions on the interval 0 to pi. Number 4 is a pre-calculus problem. We'd like to solve for x. Log base 3 of 8x minus 5 is equal to 3. We translate our statement, log base 3 of 8x minus 5 is equal to 3, into 8x minus 5 is equal to 3 to the third, or 27. So that gives us 8x is equal to 32, and x is equal to 4. Number 5 is a BC Calc problem. We'd like to find the limit as x approaches 0 from the right of x natural log of x. This is an indiscriminate form problem, as the limit as x approaches 0 from the right of x natural log of x is 0 times infinity. So we can write the expression as the limit as x approaches 0 from the right of natural log of x over 1 over x. And plugging in our 0, we get infinity over infinity, opening the door to L'Hopital's rule. This gives us the limit as x approaches 0 from the right of, taking the derivative of top and bottom, we get 1 over x over negative 1 over x squared. Flipping the bottom fraction, we get limit as x approaches 0 from the right of 1 over x times negative x squared over 1, which is the limit as x approaches 0 from the right of negative x, and our answer is 0. Number 6 is the more difficult or more complicated 5-digit answer problem. This is from AB Calculus. A rectangle's sides are changing. Its length is increasing at the rate of 5 inches per second, while its width is increasing at the rate of 4 inches per second. When the length is 8 feet and width is 7 feet, how fast is its area changing, measured in square inches per minute? To solve, we let the area A equal LW, and therefore dA dt is equal to, by the product rule, L dW dt plus W dL dt. We will be working in inches, so dA dt is equal to 8 times 12 times 4 plus 7 times 12 times 5, and that adds up to 804 square inches per second. But we want our answer in square inches per minute, so we must multiply by 60 seconds over 1 minute. And our answer is 48,240 square inches per minute. So our single-digit math answers are 84240. This is corroborated by the 5-digit answer of 48240 using the same digits. Normally, students would either do problems 1 through 5 or just number 6, but corroboration is always nice. But this isn't the puzzle answer, which is some permutation of those digits. We are now ready for the digital app. The digital app is not really an app, but it is a website that runs our digital game, similar to the original Wordle game. The URL is on every digital puzzle page, plus all over the digital page on the MasterMathMentor website. I suggest saving it as a favorite so you don't have to type it in all the time. Since we just solved the math problems on the sample puzzle 999, we type in 999 and press Go. We get our digital input page with Finucci the cat overseeing your work. There are 6 rows for puzzle guesses as well as a used digit board, just like in the real Wordle game. Using our first 5 mathematical answers, we know that our puzzle answer is a permutation of the digits 84240. Let's say, though, for the sake of argument, that problem 4, we thought the answer was 9 instead of 4. So suppose our first puzzle guess, therefore, was 20489. We see by our feedback that we have 4 of the correct numbers, but none of them are in the correct position, and the 9 is incorrect. In our second guess, we correct problem number 4, and at the same time rearrange the other numbers. We try 04824. Everything is now yellow or green, meaning that all the math is correct. It's just guesswork now. Still, it's just not trial and error. There is logic that allows you to solve the puzzle. You know the first digit is not a 0 or 2, so it must be a 4. And the last 2 digits must therefore be 0 and 2. But we know 2 is not in the 4th position, so the answer must be 44802. We have all greens, and our answer is correct. Like Wordle, digital is a combination of skill and luck. In Wordle, how many guesses to find the word of the day is based on the first couple of guesses. A lucky first guess, finding several letters in the word, makes the job so much easier. The skill then is involved by putting that information and knowledge of the English language. In digital, the skill is at the beginning, solving the math. Coming up with the puzzle answer is then a matter of logic and luck. When students solve the puzzle, they will get a comment based on the number of tries it took, plus a time elapsed. The time is taken from the moment a student first types in the first digit of his or her first guess. It obviously does not involve the time that it took for students to solve the math problems. However, if students speed through the math and make mistakes, the time it takes to correct them is incorporated into the puzzle time. This is the best aspect of digital. A student cannot start over. If they reload the app on whatever device they are using and use puzzle 999, it will bring them back to whatever state it was last in. They can start fresh on other puzzles, but not 999. There is a reset. However, information to use it is found on the digital page, and we do not broadcast it to students. Obviously, there are ways for students to cheat, but this is a game for fun and not a test. It is simply a neat way to practice and review math concepts while adding in a little competition. Probably the best way to play digital is for a teacher already having chosen the topic number before the students come in, maybe a topic that they just completed, and having the 6 problems on the class smartboard. Students go to work while teachers take care of housekeeping, such as attendance or checking homework. When students finish the problems, they pull out their laptops, tablets, or phones and type in the puzzle number on the app. When enough students have completed the work and solved the puzzle, you stop and can go over the problems. Solutions, if you choose to purchase them, are on the MasterMathMentor website, but the digital game is and always will be completely free. Students can share their results with friends or their teacher, just as in the real Wordle game. When they have solved the puzzle, they copy to the clipboard and paste their result into an email. Sorry, we don't have texting working just yet. As of now, Digital is available for AB Calculus and has 32 topics. Approximately mid-April of 2022, the SAT/ACT version of Digital will come online. There will be no announcement. One day, a Digital SAT page will be simply added to the Digital page on the MasterMathMentor website. After that, BC Calculus will come online. We will make this available as puzzles are completed. Shown are the projected topics, but these are not set in stone. It will be a challenge, for example, to create a convergence problem with a 5-digit answer, but we'll give it a shot. After that, we will be working on pre-calculus and AP statistics. It is my goal to have Digital available for all topics under the MasterMathMentor umbrella. Are you a teacher or even a student who likes to try your hand at writing math problems? I would love to see Digital for lower grades in the areas of algebra, geometry, and even basic arithmetic. That's how the SAT version got written. Dr. Sheldon Goldberg, a retired high school teacher, wrote the problems and I created the documents. If you are interested, drop me a line at team@MasterMathMentor and we can talk about it. If you're up to it, I'd love to welcome you to the MasterMathMentor team. I hope you and your students love playing Digital, and besides having some fun, their math skills improve too. Drop me a line at the same email address to tell me how you are using Digital and whether students enjoy it.